In this video, we are going to be finding the area of a regular polygon that does not give us the side length. All they give us is the apothem. And you can see that right here in the center. We have this apothem value, and it is 17 inches. Now, because this is a regular polygon, there's a trick we can use to figure out what the side length is. And I'm going to show you how to do that right quick. But it's going to require us to find a central angle. So let me go ahead and move this up and show you what I mean. A regular polygon can fit inside of a circle. In other words, right, we can call this an inscribed polygon, and the reason that it fits in there is because all these sides right here are the same size, and that's what a regular polygon is. It just means that all the sides are equal to each other in length. Now, because of this, we actually have a central angle in one of these regular polygons if we were to put it inside of a circle like this. Now, I want you to keep in mind the lessons you were doing previously when you were finding sector area, sector lengths. We would look at the central angle sometimes. And if I wanted to look at a central angle, for instance, a central angle on a regular polygon would just be from vertice to vertice. So for instance, I can go from this center right here out, and then go from the center right here out to this vertice. And this would be my central angle. Now, why that's important is because we don't know what a side length is. But if we figure out the angle of a triangle here, we can actually go ahead and use trigonometric ratios in order to find the side lengths of this particular shape. And so I'm going to show you what I mean. First of all, I'm just going to go ahead. Imagine when you're finding these, the apothem, I want you to remember, just like you've seen in the other one, the apothem cuts through the center, from the center point to one side in many of your problems. Now that forms a right angle. So imagine this forms, if I go from the center here, right, it actually makes two right triangles. The one on the right is a right triangle, and the one on the left is a right triangle. And then if I know what this central angle is that goes from here to this vertice and from here to this vertice, then I can divide that by 2 and figure out what just this one angle is. That's right here where I'm going to shade it in. And once I figure out this angle, and I know that this angle is 90, I can then use trig ratios to determine the side lengths of the triangle. So that's what I'm going to do. I'm just kind of showing you this image here so you kind of get an idea of what's happening. Right? Imagine that this is angle A. We'll imagine that this over here is angle B, and this is your angle C, right, which is opposite of the hypotenuse, the longest side of the triangle. So I'm going to turn, on the other figure, we're going to go back to it. I'm going to turn the apothem into a side of a triangle, and I'm going to show you how we can figure out what the angle is. Now, when you were doing polygons earlier, we had you figure out interior and exterior angles of polygons. So I want you to know that here in a circle, right, we have 360 degrees around a regular polygon because it makes a full circle. So 360 degrees. So if I wanted to find this whole central angle right here, this whole angle, not just the one part so I can use the trig ratio, but the whole angle, what I would do is I would simply divide it by the number of sides in the polygon. And like this one, for instance, has 1, 2, 3, 4, 5, and 6. It has 6 sides. So if I wanted to know this whole central angle, it'd be 360 divided by 6, which that'll go into there 60 times. So that tells me that this central angle here is 60 degrees, and that's this whole angle. To imagine that my polygon actually has 2 sections, or 2 angles in this one, what we call a central angle. And so in other words, if I said, okay, well, this is 6 sides, but I want to break up each side into 2 parts. So this side's 2 parts, this side right here is going to have 2 parts, and this side has 2 parts, and so on. Then I would just double the number. Instead of saying I had 6 sides, I'd say I have 12, because I'd have 1 side, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In other words, I'm just saying that each side of the polygon represents 2 sides put together. So I could do 360 by 12, divided by 12. And if I were to do that, that's going to end up giving me 30 degrees. So whether you do 360 divided by 6 and then cut that number in half to get half of a triangle angle, right, bisecting that large central angle, you could just simply take the number of sides you have on the polygon, double it, and then divide 360 by that number, and it gives you the value that you're going to need to use that trig ratio. So let's go ahead and we're going to apply this idea to the problem. Alright, in this problem, I'm going to go ahead and turn my apothem. I'm going to say this is one side of the triangle, and just to make it simple for you, I'm going to call it side A, right? And I'll call this side B, and we're going to have a side C over here in just a second. Now, you don't have to label yours on these problems you're doing. I'm just kind of showing you that I'm turning this into a right triangle. So let me go ahead and come over here to the vertice. This now is a right angle, and this is just one right triangle. Now, it does break up this side of my shape into two parts. And so what I'm going to do is I'm going to use that idea that I showed you earlier. I'm going to say 360 degrees because this is a regular polygon. It works only with regular polygons. So I'm imagining that it's in a circle and all sides are equal. And I'm going to divide it by the number of sides. Now this one actually has more sides than the one that we just looked at. And this one actually has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 sides. So since it has 8 sides, 8 times 2 is going to be 16. And so I'm going to actually divide this by 16. And that's going to tell me what the angle is right here, what this central angle is. So let me get my calculator. And I'm going to turn this on. Let's do 360 divided by 16. And it gives me 22.5. So I know that this angle is 22.5 degrees. Now that I know this is 22.5 degrees, I know that this one down here where the apothem went through is 90 degrees. And so I'm going to go ahead and set me up a trig ratio to figure out the length of B. In other words, I'm really trying to find the length of this side of the triangle. I know this side's 17. I don't have the hypotenuse, but that's not a problem. But I'm going to find this side B. And I'm going to highlight it just so you can see. We're looking for the length of this part of the triangle. Now as we're solving this, imagine here, right, if this is side A of the triangle, we're going to call this angle A over here. And if this is side B of the triangle, we're going to call this angle B, right? And just like this is side C, we'll call this angle C right here. So this point. Now with that being said, I'm going to go ahead and we're going to use tangent. Tangent is actually going to be equal to opposite, and I'm going to put tangent theta is the opposite side over the adjacent. So we're going to use this idea in order to solve it. This side 17, and this side over here we're just going to call it B. I'm going to use variable B for it. So I'm going to rewrite this. I'm going to say tangent. But we know what theta is, right? We know what the angle is. That just represents the angle. The angle is 22.5. So tangent 22.5 is going to be equal to the opposite side of that. The opposite of that side is B. We just gave it that variable. We gave it that letter. And it's going to be over the adjacent side of the angle. The adjacent side touches the angle. So this side of the triangle touches that 22.5 degree angle, and it touches the 90 degree. So that's going to be our adjacent. So that's going to be 17. Now that we got this set up here, we're just going to go ahead and we're going to use inverse operations to move some things around to get B isolated by itself. Now if I want to get B all by itself, right now B is being divided by 17. So to get rid of that 17, I have to do the opposite of dividing, which is multiplying. So by multiplying B over 17 by 17, it gets rid of that denominator. But I got to remember to also multiply the left side by 17, right? Because whatever we do to one side of the equation, we got to do it to the other side. So now that that's done, I'm just going to rewrite this. This actually becomes 17 tangent 22.5 is equal to B. And now we can go ahead and use this to find the side length and know how long this section of the triangle is, which is half of the side of this regular polygon. So I'm going to put this in the calculator, and I'm just going to write the B on the left. I like having my variable on the left. And once I put this part in the calculator right here, I'm going to write that answer over here on the right side of B. So let's put it in real quick. Do make sure that you have your calculator set in degree. If it's not set in degree, hit the mode button. and then go down until it says radian and degree and change it to degree. And then I'm going to type in 17 tangent 22.5. Hit enter, and it tells me that it is 7.041. So I'm going to write 7.041. So now that we got this side length, right, we know that B is equal to 7.04163056. That's this value right here that's highlighted, right? This side of the triangle that's highlighted yellow. So we know half of it. If we doubled it, it'd give us a full length, right, of a whole side of this regular polygon. So keep that in mind if you're going to use that idea in order to find the perimeter of this. Because remember, the way that we find perimeter, I'm going to write right here, perimeter is going to be the distance around the whole shape. Now, this particular shape, right, we had already determined it has 8 sides. So there's 8 sides in this polygon if we count all the sides going around. Now, if I just found half a side, then I have to multiply the half by 2 to get it to be equal to one side. So what I'm going to do is, instead of multiplying it by 2 and then multiplying it by 8 to get all the sides added up, I'm just going to multiply it by double the number of sides I have on the shape. So we have 8 sides on the shape, and double 8, which means 2 times 8, is 16. So if I want to find the perimeter, in other words, the distance around this entire polygon, I'm simply going to multiply this half a side of it by 16. And that'll give me the entire distance around this shape right here. So I'm going to go ahead and put that into my calculator real quick, and we'll see what the perimeter is. So I'm going to take that number, so 7.04163056, and I normally don't type it in, but I accidentally hit delete when I was moving my calculator. So I'm typing it in this time. I'm going to multiply that by 16, and it gives me 112. So let me write this down. 112.666089. Now, just to show you that we could have, if we wanted to do it a different way, we could have. If you're like, well, you know what, Mr. H, I know that 2 times this gives me one side. Now, we could have also taken this number and multiplied it by 2, right, to see what the full length of this one side is. So this one side is actually 14.083261112. That's the side length of one entire side. And we could have multiplied that by 8 sides, because our shape has 8 sides, and it would have given us the same number. But I think it's quicker that once you find what half a side of the polygon is, that you just multiply it by double the number of sides on the shape. Now, that is our perimeter, so I'm going to write right here, P is equal to this. Because a lot of the worksheets I'm seeing are asking for the perimeter. They're asking for the apothem. So I'm going to put right here, I'm going to put apothem, which is represented by the variable A, is equal to 17. And the last thing we need is the area, right? So we did all this work here just to be able to get these two numbers, the perimeter, to make sure we had the perimeter, so that we could go ahead and use the formula to find the area of a regular polygon, which requires the perimeter be multiplied to the apothem and multiplied to 1/2. So I'm going to move this up a little bit, and I'm going to go ahead and write the formula here. So the area is going to be equal to 1/2 times the apothem times the perimeter. So let's go ahead and put in our values. So A is equal to 1/2. And then what I'm going to do is, for the apothem, I'm just going to put a set of parentheses. And the apothem is 17. So for that, I'm just going to put 17 in there. And the perimeter, right, is equal to this number right here. So I'm going to go ahead and write 112.666089. And then our calculator will do all the work. And we'll get our final answer and we'll round it. Alright, so now I'm just going to enter this in the calculator. Hit alpha y equals, enter. Put my fraction bar and my 1/2. And then we're going to go ahead and put a parenthesis and then put the apothem, close parenthesis, another parenthesis, and 112.666089, close parenthesis, and I'm going to hit enter. And notice this is my area. So 957.661. Now I notice on a lot of y'all's work, your teachers are asking you to round to the nearest hundredth if necessary. And so this is the tens place. The second one after the decimal is the hundredths place. So I'm going to underline it, and then I'm going to circle the thousands place, which is 1. And that tells me whether to change the 6 to a 7 or leave it the same. And remember, 4 or less, let it rest. 5 or more, raise the score. So this is 4 or less. So we're going to leave it the same. So my final answer is going to be A is equal to 957.66. And notice that's a capital A, representing my area. So this was in inches, and when we're talking about area, we're talking about inches squared. So this is 957.66 inches squared. The perimeter was 112.666089 inches, and the apothem was 17 inches.